Hello guys. Welcome back to my channel. Today we are continuing our discussion on design smells. So without delay, let's start. Design smells are concerned with code that violates established design principles, like dry, solid, etc. These design smells can be broken down into 4 major areas. These are abstractions, encapsulation, modularization, and hierarchy. Let's see all one by one in details. Abstractions. In broad terms, an abstraction defines the objects its boundaries in code. Knowing that, design smells dealing with misused or incorrect abstractions are concerned with an object's structure and behavior. Bad abstractions can be categorized in these forms. First is missing abstraction. We can say abstraction is missing in the code when we see literal values or hard-coded strings are used instead of a data model or object. This we already talked about on our code smells video. Or using primitive data types all over the places instead of interface. Next is multifaceted abstraction, which can be seen when classes or interfaces that have more than one responsibility to handle, as it violates the single responsibility principle of solid principles. The solution here would be to break off the 2 or more responsibilities and shift into its own class. Similar to duplicate code, duplicate abstractions can also be found in code bases, meaning there are classes or interfaces that share the same name or have the same behaviors or both. These are most common than you might think, as catching them requires careful code reviews and refactoring, which gets overlooked sometimes. Our final bad abstraction is the incomplete abstraction, which happens when a class or interface doesn't fully support a responsibility. Next, design smells is generated via encapsulation misunderstandings. Encapsulation encapsulates the elements of an abstraction, separating the interface from implementation. Design smells in this category deals with accessibility of abstraction members. First kind of encapsulation design smell is deficient encapsulation, which happens when an abstraction's implementation and/or members are poorly protected. This leads to data vulnerability and behavior misuse. Second type is unrestrained encapsulation, which more severe case of accessibility control. This design smell occurs when an abstraction's state is not just poorly protected, but globally visible and modifiable. This can lead to even more data corruption and behavior abuse by outside abstractions. Third type of design smell is unexploited encapsulation, which happens when code uses explicit type checks, like excessive if-else or switch statements to check the type of an object instead of exploiting the type variation that's already encapsulated within a hierarchy. The solution in these cases is to use polymorphic methods in the object itself so that the code isn't responsible for the type checking. This will add benefit of decoupling and make modification much easier and safer. Third category of design smell is modularization. A system is modular if it's decomposed into cohesive and loosely coupled modules. Design smells in this category are concerned with how well is the abstractions and how independent they are of each other. First type of modularization smell is insufficient modularization. This smell comes about when an abstraction has not reached its ideal decomposition, meaning it's either too large or its methods are too complex and need to be broken down further. The solution here is to decompose code all the way down to that base level and make sure it follows solid principles. Next smell is broken modularization, which happens when data or methods that should ideally be grouped in a single abstraction are spread out across multiple abstractions. Solution here is identifying like-minded behaviors and information in your programs. Third modularization smell is cyclically dependent modularization smell, which you can see when abstractions are heavily dependent on each other and tightly coupled and classes have inappropriate intimacy code smells. The solution here is to either refactor those dependencies out of the coupled abstractions, or to use dependency injection to decouple their implementations. Let's move to our fourth category in design smell, which is hierarchy. Hierarchies are ordered abstractions. Smells in this category are focused on how these abstractions are structured. First hierarchy design smell is multipath hierarchy, which happens when a base abstraction is repeatedly inherited in a derived abstraction, which forms this nice little polygon shape in hierarchy diagrams. These types of hierarchy is warning signs to you. The solution here is just to remove the redundant inheritance and streamline your abstraction hierarchy. Next is broken hierarchy smell, which happens when a base class and a derived classes don't share an is-a relationship like they should. This violates L.S.P. of solid principles. This usually happens when inheritance is used instead of composition when laying out said abstractions. Now this smell is particularly dangerous because it allows behaviors to be shared between base and derived abstractions that shouldn't be allowed to have that communication. One straight solutions here are to replace the inheritance relationship with either a component or delegation structure. The last design smell we'll look is cyclical references. This smell occurs when a supertype in a hierarchy depends on any of its subtype. These design smells, however, is not the complete list. There are many design smells, however. I'll use as Grady-Booch fundamentals principles for classification and naming of smells. The acronym FAME means Principles of Hierarchy, Abstraction, Modularization, and Encapsulation, is sometimes used to refer to these four fundamental principles. Don't forget to subscribe to RG_semicolon. See you in the next video. Thanks for watching. Bye.